Okay, class, picking up where we left off at. We have $22,234.51 billion, dollars, which we need to rewrite as 22.23451, and this would be trillion dollars. This is what this actually means. Now, if we scroll back up, let's scroll back up to our chart. Now, if you look here at our chart, the largest number we have is 14,764, which is actually 14.764 trillion. Now, if we scroll back down here to our current problem, let's go back. We're at 22 trillion. So what that means is that this is extrapolation because it does not fall within the data that's given. So that is our final answer. It's extrapolation. Now, we go on to the next page here, which gives a few Ti84 calculator instructions. You can read those at your leisure. And also, we have the website down here at the bottom that you could easily go to and follow the steps for this particular page. Also, on the next page, it deals with the Excel instructions, which basically is the same thing. You will follow these instructions, and you will be able to do this graph on Excel. Now here's the website to learn how to do it on Excel. Now, if you have an older version of Excel, you will have to change a couple things in order for it to meet the specifications of what you would see from this explanation of Excel. Now we scroll here to page 26. It says example 4, for each data set, complete the following. A, create a scattergram of the data with the calculator and draw a sketch. B, explain why linear or exponential model is more accurate for the data set. And C, if a linear model is more appropriate, find it using regression and explain the meaning of M and B. Or if an exponential model is more appropriate, find it using regression and explain the meaning of A and B. Okay, so we need to get started here. It says the number of farm-raised trout sold in the U.S. T years after 1990. So of course, you know, we have to make another line here. We know our T value, and as you see, this is jumping a little bit here. So let me adjust this. Okay, now the necessary adjustments have been made. This L1, remember I told you you need to rewrite this. If you notice, since it's from 1990, 1991 will be 1, 1993 will be 3, and so on. That will be your L1. Now you know the trout sold in millions is actually your L2. So now, what we would need to do is this here. You needed to put it in your calculator and get the graph. I know my line is a little off here, but let's see, we have 34, 73, and 22. Now, if you notice, your lines are going to go down a little bit. Okay, so now we have these values here. Now, this is a sketch of the graph, which we were asked to do. Now we will go to B, which is determine if it's exponential or linear. You know, if you do your line, this is going to give you a linear line. So this is linear, because it's going to give you a straight line instead of the curved line that you need for an exponential function. It's linear because the points do not form a curve. And once you put this in as your linear regression, we will have, which is C, we have T of T is equal to, I didn't give myself enough space, so you know this is all going together. It'll be a negative 1.16 T plus 67.52. Okay, now we have to tell what our M and B means. So we could write down M, our slope is a negative 1.16, which means that every year the number of farm-raised catfish, or I'm sorry, farm-raised trout is going down by 1.16 million. Now we have to find our B. Now our B is equal to 67.52. And this means in 1990, there was 67.52 million farm-raised trout. In the U.S. Okay, and that's the final answer for data set 1. Now we go here to data set 2, and it says here, the number of children per every 1,000 that have been diagnosed with autism in the U.S. at T years after 1970. Now when we look here at this chart, you notice that it's after 1970. This T right here is actually our L1. And the number of children with autism is our L2. So from 1970 to 75 is 5 years, 85 is 15, and so on. Now we want to draw a little graph here. So this would give us, that's a negative 1.7. We have 1.7. We have 14. And now we will put these values here. Now if you notice here, this is going in a curved line. So, well, actually the points curve. So B is exponential. And we know it's because the points curve. So now we go to C. We will get the exponential regression. So we will have A of T is equal to 0.0082 multiplied by 1.14, and we know that's to the power of t. So now we have our formula. Now we have to tell what our a and b means. Now a is equal to 0.082, which means in 1970, the number of children diagnosed with autism was only about 0.082 per 1,000 children. Now that is A. Now B, we have 1.14, and we notice that this is greater than 1, so we know that it's going to be increasing. So we'll have every year the number of children being diagnosed with autism in the U.S. is growing by Now, what I want you to do, I want you to figure out how much this is growing by. Okay. So what you were supposed to do here was make this 114% minus your 100%. And that will leave you 14%. So that is how much it's growing by, 14%, and we're done.